Okay, guys, are we still good?
Yeah, I got you.
Okay, well, we're going to go ahead and get started. So you guys want to get pen and paper? There are a few things you need to write down. I want to go over, and then we'll have a short lecture. So first, I want to welcome everybody to Logic Control. I read through the roster. I think most of you I've had in the circuits course, so I'm familiar with a lot of you. Haven't seen you in a couple semesters, but I did recognize some names, so welcome back and glad to be in front of you again. I posted the website went live on Sunday, yesterday. I sent out an announcement, so hopefully you got a chance to kind of browse through the website. If you did, you want to do that. Go through the website and look at some of the material for the first week and just get familiar with the navigation. This is my first time using Canvas, so you guys might be more familiar with it, but get used to navigating through Canvas. I made a front page for my website, so make it easier to kind of find documents. So you can just go to the home page and click to get right to the course material that we are on at that particular time. Now, as far as the way we're going to meet, today we're using this Blackboard app, which it's okay, but it doesn't work well for if I want to share files from my computer, like a PowerPoint or some other document or other application. The Blackboard doesn't work well. That app doesn't work, and they're doing away with Blackboard. So the reason I sent it out is because everybody can click on the link and come directly to the session. But we're going to move over to Zoom. I don't know what the other professors are using, but I'm going to go ahead and use the Zoom app. So with the Zoom app, if you haven't used it before, what you'll need to do is download a small app on your device, which is the reason why I didn't use it for the first lecture. Because if you don't have that device, it's a little hard. I don't want you to try to download it at the last minute. So today we're using Blackboard to do this stream. After today, we're going to use Zoom. So what that means is between now and next lecture, well, I'll probably later today or tomorrow, I'll send you out a link. If you have not used Zoom before, you want to click on that link, and what it'll do is it'll download the app that you need on your device, and you'll do a test session to make sure it works. And then on Monday, we'll be up and going through Zoom. So make sure you do that. And all future lectures will be done through Zoom. You want to make sure that when you get on either this app or Zoom, that you want to make sure you mute your mic. If you have a question, you can unmute the mic and then mute the mic back. And I probably don't have to say this to you guys, but remember, some of you guys have your cameras on, and I've seen a lot of stuff in the background that I shouldn't have seen of other classes I've taught. So just remember that you're online and you're on camera. Issue because I'm recording this, and what I'm going to do is post this. So if you want to make sure everything is kosher, if you know what I mean. Things that you'll need for the course. So I made a list of things that you'll need for the course. Now I know I'm in this room that I just kind of threw up to make a lecture studio, and the lighting is really, really bad. So I know there's some reflections on the board. So hopefully you can see it. Over the next couple of weeks, I'm going to try to improve the lighting a little bit. But if you can see the board, you will need a 3-ring binder. If you had me before, it's the same old thing. There's a lot of handouts. I did take every handout that I had for this course, I made into a web page. But if you notice, if you went to the website, I also made all the web pages, or I'll say 90% of the web pages are downloadable. So what I would highly recommend is that you get a 3-ring binder and a hole punch. And if you have the ability to print, which you really do need the ability to print, I would print out each page and just put it in the 3-ring binder. The reason for that is, well, I've been teaching this course since 1999. And around 2004, I got rid of the book because the book kept going up in price. And students had to pay more and more, so I just said, the hell with the book. I got rid of it. I moved everything to PowerPoint. I don't like teaching for PowerPoints, but it's the nature of the material that when you have to just describe a lot of stuff, we use PowerPoints. And so I made my own PowerPoints back in 2004, and I've been using those ever since. So if you can print this stuff out, the PowerPoints, the documents, 3-hole punch it, put it in a 3-ring binder. You basically have a book, the textbook that you'll need. If you don't, you can always just save it online. You can have it there too, or you can just use the website. There will be some things you need to print though, because there's some things you have to fill out by hand, unless you guys know another way to write on a PDF or something like that. You might know something I don't, because I know you guys are familiar with all these apps and all the stuff that's out there. So I'm going to recommend you get a 3-ring binder. You don't have to have it, but I highly recommend it. It'll help you stay more organized. You need the ability to convert a document to a PDF. Now, what we did last semester, there was this app, and I'll give you the name of it. And you may have an app similar to this, or you may have another way to do it. But there's an app you can use on your phone. You take a picture of the document, it automatically cuts out the background and turns the picture to a PDF, and then you can send it to me in PDF form. So I'll send out the name of that app, and if you want to use it, you can. If you know another app that you can use to do the same, that has the same functionality, you can use that. Or however you do it, as long as you have the ability to convert a document to a PDF, you have to be able to do that. Now, there is one book you'll need. There's a lab manual that you will need for the course. I think the ISBN number is on the syllabus, but I want to make sure that the problem with the lab manual and the textbook, there's a lab manual, there's a textbook, and there's an activities manual by this author, and they all look the same way. All the covers are the same. If you don't read closely, you'll think you're buying the lab manual and you're actually buying the textbook. So what I'll do is I'll probably make a copy and put up the actual front cover of the lab manual that you will need on the website, and then you guys can look at it. So make sure when you order the lab manual, make sure it says lab manual and not activities manual or textbook. I think I had like a couple students do that last semester. They ordered the wrong book. Now, I did not order the book in the bookstore for the same reason I got rid of the textbook. They kept going up on prices. I don't know how you guys can afford to pay for these books. I mean, it's just crazy. So the lab manual got up to be over $100, and I said, to hell with that. You can really use a older version of it. And that's what I had the students. We actually voted on it last semester. I asked the students, how many people want me to order it, put it in the bookstore? Nobody raised their hand. Nobody wanted to pay over $100 for the book. How many people want to get it online for, I had one guy get it for $10, $20, whatever. You can get it online a lot cheaper. It doesn't have to be a new one. There's a couple editions you can use. So you won't need that lab manual for until the 6th week of class, so we got time. But I would recommend just kind of looking for it. That way, when it comes time to do the lab, we can hit the ground just running. You don't have to try to get the manual. So this is anything you have to have right away, but just keep in mind there will be a lab manual, and I'll post up the front cover of it so you can see what it looks like. And if you find an older edition, you have any questions about, hey, can I use this one instead of the other one? I think the one we use is the 4th or 5th edition. But if you want to know if you can use another edition, just ask me, and I'll let you know. Now, when we actually met face to face, and when I ordered the lab manual in the bookstore, the lab manual came with a disc in the back that had the software simulation on it that you needed. This course, when we taught it back on, I don't know, probably around, well, before the colleges merged. I don't know if you guys know the story, but the College of Applied Science and Engineering were actually 2 different colleges at one time. And when we were 2 different colleges over on Victory Parkway, we actually had a lab. I don't know if you guys still go over on Victory Parkway or not, but there was a PLC lab, and me and Mark Faxler, I taught the theory back in the day. He taught the lab, and you guys would actually go in there and program an actual real PLC and put hands on the sensors and all of that. Well, we don't do that anymore. So the next best thing is this software simulator, which actually works pretty well. So I think some of the lab manuals will say CD-ROM on it. If you're lucky enough to get one of those, order that one, and then you'll have the software in the back. The problem with that is if you order something used, you don't know if the CD is going to actually be there or not. So there is a place you can go download the software. I think it's less than $40. I think it's around $35. So you will need that simulation software to do the course. But again, you won't need the manual or you won't need the simulation software until the 6th week. However, do not wait until week 5 to try to get it because you may have a problem. I'll say around week 2 or 3 you want to start looking for this stuff. I'll put up the link for the simulation software. I'll put that up over the next couple of days, and again, I'll put the front page, the front cover of the lab manual on I want to say Blackboard. I'm going to say Blackboard. When I say that, I mean Canvas. I'll put it up on Canvas, and you guys will have access to it, and you can see what it looks like. So I'll remind you again in a couple of weeks and say, hey, start looking for the lab manual and the software. And probably the earlier you get it, since people are going to buy the used copies, the earlier you get it, the more able you'll be to find it, and probably the cheaper you'll be able to find it. Because if I'm not ordering this through the bookstore, eventually the supply out there is going to dwindle, and people are going to find it harder and harder to get. And I imagine at some point I'll have to order it in the bookstore, and the students will have to pay $150 for a lab manual again. But right now, we'll get it online. You'll get it cheap. So here's the stuff that you need. All the lectures. Okay, let me back up. So I'm going to stream these lectures live, and you are required to come to participate during the live stream. But I'm also going to record the lectures. Now, I was hesitant last semester. Should I record these lectures or should I have it live stream? If they miss it, they just miss it. Well, I decided to record the lectures, and I posted the lectures on Blackboard. I posted the lectures where the students could get to them. And I think it worked okay. Now, the fact that I'm going to post the videos does not mean, okay, I don't have to come to lecture. I'm going to just watch the video. The reason I'm doing that is I know there's things going on. There's a lot of stuff going on now. If you miss a lecture, you will have the ability to go back and look at it. But please don't substitute the video for the live stream, because there's going to be some things that we need to do where you guys are going to actually participate, and there's going to be a back and forth between me and you and the whiteboard. We're going to work problems. I guess part of the class is PowerPoints. There's some of the PowerPoints. There's some problems that we work, and there's some programming stuff. Well, the programming stuff you do on your own, but the problems that we work and the PowerPoints we'll do live. So you do need to sign in, and you need to be here. But if you do miss, sure, it will be posted. I think what I'll do is just probably post the links to Canvas of all the lectures, and you can just click on it. If you miss a lecture, you can go right to it, and it shouldn't be a problem. What else? So on here I have the website, the class website. I'll update that weekly. Usually on Sundays I like to go in and update the website. I know when I was doing Blackboard, I would like to do it on Sundays, because Sundays usually is the day I grade. But I had some students that say, hey, it'd be nice if we can get at it on Friday, because some of you get to the stuff early and you want to be ahead of the game. So I'll definitely have everything posted by Sunday. The website will be updated, but I'll try to do it by Friday so that you guys that want to work ahead or read ahead, that you're able to do that. Now, if you had me for any other course, I use these things called topic sheets. I'll pass out a topic sheet. If you had me for the circuits course, the topic sheet was basically an overview of the chapter. And when I make exams and quizzes, it's kind of based off the topic sheet. Well, I have the same thing for this course. It's a topic sheet. Now, when I have a PowerPoint, I won't do a topic sheet. You don't need it. The PowerPoint is a topic sheet. But this week we have a topic sheet, so I want to make sure you look at that. And for the quiz, you'll have a quiz this week. You won't fail the quiz. It'll be something that's impossible to fail. But the quiz next week will be over material from this week, and you want to make sure that you look over the topic sheet, because the quiz will be based on the topic sheet. And actually, for the first week, I have a list of objectives for the first week. If you got a chance to go to the website, look at that list of objectives, and you'll see what I'm saying. If you did not, just make sure you do that by tomorrow. The reason is I'm trying something new. I never in my life have given extra credit. I've been teaching since 1996. Some of you weren't even born in 96, but I've been teaching a long time. I never gave extra credit. I didn't really believe in it. But I decided that with all this going on, I'm going to try extra credit. So if you, it's not on the syllabus. It's not listed on the syllabus, but there is an extra credit that's worth 2% overall. So with that and the homework, which people usually do well on the homework, that's a nice bump to your grade if you do the extra credits. If you don't do the extra credit, it won't hurt you. It will not hurt you at all. It can only help you if you decide to do it. So I'm saying that to say there's actually homework 1 is posted right now. It's posted, and I think it's due on Wednesday. You want to look at the due date because the link is set to expire after the due date, and then you won't be able to turn it in. But along with that, there's an extra credit. It's a real simple extra credit you can do, and I highly recommend that you guys do all the extra credit that you get. This course is not, I mean, it should be, I don't want to say it's an easy A, because when I say easy, students confuse the word easy with what they already know. But it should be a fun course, and it should be, as long as you're serious about it, you practice it, it shouldn't be that big of a deal. I mean, if you're taking other courses, this shouldn't be a big burden to you. This course is pretty straightforward. But still do all the extra credit as an insurance policy. And then I want to go over the syllabus. So I don't know if you guys, if you had a chance to print out the syllabus, if you can bring it up on your screen, or if you just want to listen to me talk about it. But I think most of you know me, Ron Singleton. Please call me Ron. On the syllabus is my, I don't have my UC email. I have my personal email. Now you can send it to my UC email, but I got a UC email. I got all kinds of emails. The one I check most of the time is the one that's listed on the syllabus and on the website. So you can send me an email to my personal email, but you want to put UC student in the subject line. I have a UC folder. It'll go right into that folder, and I can click on it and check to see if I have anything message from you. Never ever email me any document unless we agree upon it first. I don't accept any assignments by email. What I get is students will miss the link will expire, and want to turn it in anyway, and they'll email it to me. So if you email it to me, there's no guarantee I'm going to get it. If it's late, I probably won't accept it unless we've talked about it first. So if we talk about it, I say, hey, yeah, go ahead and email it. What you want to do is email it to me to the Hotmail account. You want to put UC student in the subject line, and you want to make sure you follow the email with the text. Just text me and say, hey, this is so-and-so. I sent you an email, and then when I get to my computer, I'll download it and put it in the Logic Control folder, and I'll get to it. So the information is on the syllabus. On the syllabus, I have my office number, which of course we're not using. The other number is I don't have a cell phone. I think you know that, but I do have a Google Voice number. I have that because I know people like to text. So pretty much everything you can do with a phone is, calling wise, texting, you can do that with the number that's listed on the syllabus. So that Google Voice number is the fastest way to get a hold of me if you need to get in touch with me is by texting me. If you text me, make sure you say, I'm Joe Blow, I'm a UC student, and then you can ask me your question or make your statement. Remember, it's not a cell phone, so I will not respond instantaneously. I will only respond when I turn my computer on and I go to my messages and I see that you sent me a text. I'll respond. It won't be right away, but I get to it pretty fast. The text I have listed, we talked about the lab manual. Don't worry about that right now. The software we're going to use is called Logix Pro. Again, don't worry about that right now. You'll either purchase that if it's not with your CD, if with your lab manual is a CD, you'll purchase it, you'll just download it to your device. Now, if there are actually engineering students that use Macs, and that was when I was in school. If you're an engineering student, you use a PC. If you're an art student, you use a Mac. I don't know if that software runs on the Mac, or if you're using a Chromebook. I don't know if you'll have to check that out. So that's another reason why you want to make sure you get the software early to make sure that you don't have any software issues. Don't wait until the day before lab and then decide, hey, I'm going to download this, install it, and then find out it doesn't work, because then you'll be screwed. So make sure you test it out. And again, I'll have you around week 2 or 3 and say, hey, look for your lab manual. Let's get the software. Let's test it out, and then we'll be ready to go week 6 when we do our labs. So if you don't have a syllabus in front of you, There's quizzes, homeworks, exams, and labs. The quizzes are 10%, homework is 10%. There will be 4 exams, 60% total for exams and 20 for labs. And then what's not included in the syllabus is the extra credit that I told you about, the 2%. So 102% is the total max for all the assignments. The quizzes are on Fridays. You'll have, I don't know how I'm going to do the quizzes. I have to work that out. Since we're doing this remote thing, I guess I'll have to, I don't know, I'll figure it out. The one on Friday will be so easy it's silly, so don't worry about that. But after that, I got to see how to do it. I don't like multiple choice stuff, but this remote stuff lends itself to doing those things that you click on something and it grades itself automatically. I'll figure it out. That's on me. Prereq, I think most of you have had the circus course. You don't really have to have it. If you had a circuits course or similar course, it'll be helpful, but you can get through the course without that. I mean, there's some basic electrical circuit stuff in it, but I explain it, and it's not a big deal if you haven't had that. You can read the course objective yourself, the course content, you can read that yourself. I won't bore you with that. But on the second page of the syllabus and on the website is the topics listed by weeks. And if you don't have it in front of you, you want to make sure you go look at it when you get a chance, because there's a list of what the topics for each week, and some of the topics are printed in blue and some of the topics are printed in red. And the reason for that is basically the blue weeks, we meet Monday, Wednesday, Friday. That's going to be week 1 through 5. Week 1, 2, 3, 4, and 5, we'll meet Monday, Wednesday, Friday from 1 to 2 as scheduled. After the fifth week, then that's our lab time, and that'll be week 6 through 10, and that on your syllabus is colored in red. Those weeks, we'll have a lecture or we'll meet only on Fridays. Now you might wonder, okay, what happened to Monday and Wednesday? That's going to be time for you to do your lab, to work. I don't care if you don't want to share work. If you talk to each other about the work, I don't care about that. So on those days, those weeks, we'll only meet on Fridays. And on Friday, I'll give you a quiz of some sort, and that's when you'll hand in or upload, or you would have uploaded your lab. I will only set up anything late or emailed. When you upload it, it goes right into the grade book, and I can grade it. If you email it, it's an issue. So if for some reason, I had a guy that he was in the Army, he knew he was going to be out of town last semester. So we worked it out to where he can get his labs to me through email. As long as you work it out, I'll take it another way. But if it's not worked out, you have to upload it to Blackboard. And remember, those links will expire. I usually have them set for midnight, but you always want to check to make sure the time that they expire, because after that, it's late, and then I won't accept it, and that's going to really hurt your grade. So just to make a long story short, make sure you look at the syllabus if you haven't already done so. Also, I think there's 2 holidays, Memorial Day, which is in May, and then Independence Day, are 2 days that will affect our schedule. So Memorial Day is a Monday. We won't meet, was it the 25th, I think? And then we observe Independence Day on the 3rd. That's a Friday. We won't meet for lecture on those days. So at this point, does anybody have any questions on anything I talked about so far? Any questions or comments? Are we good? Okay, I assume your silence means that we're good. So let's just talk a little bit about the material of the course. And I highly recommend that, even though this is on video, take notes, guys. Write some of this stuff down. I'll try to emphasize when something's going to be on the quiz. I'll try to emphasize that, but you really want to write this stuff down and take good notes. So the name of the course is Logic Control. Logic Control. So for now, I want you to think of logic as either questions or statements that can either be true or false. So it's these questions or statements that can be true or false. And depending on the true or, I don't know if the word falsity is a word, but depending on the true or falsity of some set of conditions, you can have something happen. You can have a light turn on. You can have something happen. That's the control part of it. So we make some kind of decision or a set of decisions that can either be true or false. And I'll explain this in a more rigorous way soon. But you can have these things that are either true or false. And depending on how things are set up, based on the true or falsity of the set of circumstances, you can control something. And by control, I mean you can turn something on, you can turn something off, you can have something speed up, you can have something slow down, etc. I can control something based on these set of, I'm going to call them functions. Let's talk about logic functions. So we have these logic functions. And there's what we call the basic functions. Basic functions. And the basic functions are, there's what we call AND logic, OR logic, and NOT logic. Or there's an AND function, an OR function, and a NOT function. So these are the basic functions. And then there's these what we call universal logic functions. This will be the NAND function and the NOR function. So these are the basic logic functions, and any other logic function can be made from these three. So I'll show you when we get to this. You can make a NAND from those three. You can make a NOR from those three. And over here we have other functions. And the other ones are, one is called XOR. That's the exclusive OR. And then there's an XNOR. And this one right here turns out to be pretty important for what we're going to do in this class. So write all of this down, and I'm going to try to make this make sense. We're not going to worry about the universal functions and the other ones. We're going to start with the basic functions. I want you to understand these basic functions. So let's talk about AND, OR, and NOT. But before we do that, we got to talk about switches. So let's talk about switches. So a basic switch, like I might have a battery, and I'll draw a switch like this. All right, so I got that switch, and I got a light bulb. And if I close the switch, if I make contact right there, of course, current can flow through the circuit and the light bulb will light up. But I want to look at that switch. Let's look at the switch closely. Just the switch. If you look at the switch, what I have is I got the wire. It connects to the switch. And then I got this part over here and then another wire. This is the part that moves. So when you turn your light off or on, or anytime you move a switch, you're moving this thing right here. You can move it. Right now the switch is open. If I push this down, it'll look like this. And this switch is closed. So you can move this thing back and forth with some kind of lever or some kind of mechanical device. The thing that you're moving is called a pole. A pole, P-O-L-E. I don't know if you guys can see that in the camera or not. So that's a pole. And when you move the pole, you can move the pole. When you move it down to this position, this part that it touches is called the contact. So this is a contact. That little thing. And so when you move the pole and you close the switch, the pole touches the contact. Well, there's actually some language that applies to this I want to make sure you're clear on. When you name a switch, when you name it after the number of poles that you have and the number of ways you can move the poles to make contact. Now make sure you understand what I just said. When you name a switch, you name it after the number of poles that you have and the number of ways you can move the pole to make contact. That's called the throw, like you throw a baseball. So if I'm going to name this switch right here, how many poles do I have? I got one pole. So this is a single pole. How many ways can I move that switch to make contact? I can only throw it one way. So it's a single pole, single throw switch. You would say a SPST, single pole, single throw. If I wanted to, I could do something like this. What if I had, I can have a wire here. I can have a pole here. I can have a wire there. Now, how would you name that switch? What would you call it? Well, how many poles do I have? I still got one pole, so this is a single pole, but I can throw it to the left or I can throw it to the right. So this will be a single pole double throw switch. You would ask for an SPDT, and they would know what you're talking about. Or maybe I'll do something like this. Maybe I have a situation where I have a switch like that, and there's the contact, and then below it I have another pole and contact, and in between these I got this dotted line like this. And what that means is that when you move the lever, that both of these poles move in sync, they move together. So when I push this down, both poles will touch both contacts. So what is this? This is a double pole, and I can only throw it one way to make contact, double throw. So DPDT. So you should be able to name a basic switch like I just did, and then you can go to YouTube or Google and you can see this kind of stuff. So you got to understand the switch, the pole, the throw, the contact. Okay, so if you understand that, and there's one more thing that you got to understand when you deal with switches that's very important for this class. A switch or button, and you know the difference between a switch and a button. A switch or button can be normally open or it can be normally closed. Now that's really, really important. Let's talk about it. Normally open. I can have this switch, and you've all seen a switch like this. Your light switch on your house is like this. You turn it one way, the light is off. You turn it the other way, and the pole is down here, the light is on. But if I wanted to, I can have a spring, a little spring, a spring, pulling that pole up, keeping it up. And the only way to, when I push it down into the closed position, when I release it, that spring's going to pull it back up. You've seen a lot of, let's talk about a button. Let's apply this idea to a button instead of a switch. So a button is a little different than a switch, because a button, I'm going to have these two sets of contacts like this, right? And I connect the wire here and the wire there. And my pole, instead of moving back and forth on the pivot, my pole's going to look like this. And then this is the part that I might have a plastic cap there. I can push that down. If I push that down, it looks like this. I push that down. That's a closed button. Now, what I could do though, here's the important part. If I wanted to, what I could do, I can take a spring and I can put it in here like this. So that spring is putting an upward force on that pole. So now what happens when I push it down, when I close the switch, it'll make contact, but when I release it, that spring is going to push the pole back up and it's going to open the button back up. So if I took that button and I laid it on the table, if I didn't touch it, that button would look just like that. It would be open. That's called a normally open, in this case, push button. The idea of being normally open is critically important to this class. If I lay that switch on the table, I step back from it, no human interaction at all, that device is open. The pole and contacts are open, normally open. This is how your doorbell works. You press the doorbell, as long as you hold the doorbell, there's electrical continuity. When you release the doorbell, a spring pushes the pole back up, the doorbell doesn't ring anymore. Normally open. Now, there's no reason though why I can't do this. What if I did this? I took the same push button, but I did this. I got my contacts. This time I'm going to put my pole down here like this. Here's the thing that I push. And I'm going to put the spring down here like this. The spring is down here pushing up on that. It's pushing up on that, keeping that button closed. And what I have to do to open it, I got to push it. To open it, when I open it, it looks like this. But because the spring under it, when I release it, it's going to push it back up and close it again. This is called a normally closed push button. The light in your refrigerator works like this. Or on your car door. If you open your car door and you look at the door jamb, or you look by the post, the column, the door, there's a little button there to turn your interior light off and on. It works just like this. You close the door breaks contact, turns your light off. You open the door, you have a normally closed push button. It closes the circuit and turns the light on. So the idea of a device or switch being normally open or normally closed is very important. If it's normally open, that means when I lay the thing on the table, no human interaction, the contacts are open, that's normally open. If I lay it on the table, back up from it, no human interaction, it's normally closed. So if you understand that basic discussion of switches and this idea of being normally open and normally closed, let's get into a little bit of what we mean by logic. So I want to look at AND logic first. So what we like to do is have electrical circuits use logic to make decisions based on certain criteria. So here's what I'm saying. Let's look at AND logic. Now this is a really simple example of AND logic. All right, so suppose I had this circuit. I got a power source, and I got two switches, like that. And I want to hook up, it could be anything. We'll hook up a light bulb, it could be a motor, a conveyor, whatever it is you want to control. I want to do a light bulb. There's a light bulb. Here's my power source. We're going to call this switch A, and this is switch B. Now, what I want to do is, if a switch is open, we're going to say that it's false. The state of the switch is false. If a switch is closed, we're going to say the state of the switch is true. And so what I got to do here is write down all the possible combinations for switch A and B. I mean, they can both be open, and one can be open, I got to write down all the possible combinations. So I do that using a table called a truth table. Now the truth table is just, I go A, I go B, and this light bulb, that's my output. I'm going to call that X. That's the light bulb. And I'm going to make this table. like this. Now, if that light bulb is on, I'm talking about the light bulb here. I don't know if you can see it. Hopefully you can see here. If that light bulb is on, we're going to say it's true. If that light bulb is off, we're going to say it's false. So basically, instead of using open and close and on and off, I'm using true and false to represent that. So I got to get all the states of the switches in this table. Now, it turns out, now I'll show you how you can figure it out. There's a little equation you can use. But there's going to be a situation that if I start like this, both switches can be open. So this would be false, and this would be false if both switches are open. Now to get all the possible combinations, what you're going to do is I'm going to start over here right before the output, and I'm just going to go false, true, false, true. I'm going to stagger these like this, alternate these like this. False, true, true. And this will be false, false, true, true. False, false, true, true. Now, if you do that, you got all the possible combinations of those switches where they can be open or closed. Well, if you look at this, it doesn't take much to see that the only way to get that light bulb to come on is both switch A and switch B have to be closed. So the only place in this table that I can write a true is down here. Put a T right there. If I open this one and close that one, that won't work. The light bulb is off. If I reverse that situation, that won't work. The only time I can get this to come on is because of the way they're hooked up. Both A and switch B have to be closed. So my true is right here. In every other state, I got falses. This is what I mean by AND logic. If any kind of condition you're trying to control, where you need two things to be true in order to have some event happen, you want to use AND logic. Now, I'm only using two switches. I can have as many switches as I want. 3, 4, doesn't matter. But with AND logic, all the switches would have to be closed, because if you remember from your circuits course, they're hooked in series. So for AND logic, each input has to be true in order to have a true output. That's AND logic. Well, let's look at OR logic. How would I change this to OR logic? Well, we just rewire the circuit. OR logic works like this. I have A. Oh, let me give you the circuit. So here's my circuit. Now this time what I'm going to do is put the switches like that. And here's my light bulb. Now if you remember from the circuits course, you might remember this is a parallel circuit. So I have switch A and I have switch B. So if you're taking notes, go ahead and write down the truth table for this. This should be easy to see. This is switch A, B, and here's my output X. So let's write the truth table for that. You go ahead and write it down on your paper if you're taking notes. Well, it's pretty easy to see on this circuit. Let's say I leave B open and I close A, I got current through this path. Or if I leave this open and close B, I got current through this path. Or if I close both switches, I got current through both of these and it gets to the light bulb, it lights up. The only time I will not have current to the light bulb, I won't have a true here, is when both switches are open like they are right now. So for any state in my truth table, this state, this condition of the switches, this one, these are all true. The only time this is going to be off or false is when both switches are open. It'll be false for that condition right there. This is what I mean by OR logic. So if you're trying to control a motor, machine, whatever, any kind of device you're trying to control, And the criteria is I need for one condition to be true, or the other condition to be true, or both the conditions to be true. Now we use OR logic. Now, not is a little hard to explain, so I'm not going to really give you an example for that, other than to say that for not, we're going to think of a push button for now. This is a normally closed push button. And that for us is we're going to use that to represent not. And with not, now for and for or, I got to have at least two variables, two switches. I can have more than two, but it's got to be at least two. So the and function's got to have two inputs. But the not is only one thing to talk about. So it's hard to understand. So I think the understanding will come later. But let me just give you the truth table. So for not, let's say I have, this is switch A. So this is switch A. So if this is my A, this is true. We'll make that false, and that's true. This will be true, and this will be false. So the thing to understand about not is whatever state the original switch is in, on the output, I get the opposite state. Now that's not going to make a lot of sense right now, but it'll make sense later in the course. So the thing to do here is to get these truth tables down. Understand the truth tables, and it kind of explains, the circuit explains the truth table. Now you can imagine here that what I can do now, where these are really simple circuits, but suppose I have some complex situation I'm trying to control. What you start to do is you hook up these switches in series and parallel to give you what we call and, or, and sometimes we'll use one of these, and, or, not logic. And by hooking these things up in different combinations, you can actually control a really complex situation. But we got one problem. What we're trying to do in this class is automate something. The problem with a switch or a button is I got to push it. I got to push the button. I got to throw the lever on the switch. That's not automating anything. You got to push the button. What you really want is some kind of device like a computer or a microcontroller. You want some other device to control the switch for you. So if there was some kind of a electrical switch that we had, we can connect to a device, then we can automate all this stuff and make it happen by using some kind of a program. Well, it turns out that there is a way to do that. Using a device called a relay. Now, if you had a chance to go to the website and click on the first week material, the very first page in there, I believe, is the first or second page is a picture of a relay. So make sure you look at that. Print it out, put it in your binder. But I'm going to explain to you how a relay works, and then you'll see how we can automate this stuff. Now, a relay is just two pieces. Now, to understand a relay, you got to go back. Three things you got to understand. You got to understand that, go back to your 7th grade science class, and if you had me for circuits, we talked about this and we talked about magnetism. Anytime you have current flowing through a wire, there's a magnetic field that exists around the wire. Anytime you have current flowing through a wire, there's a magnetic field surrounding the wire. Now, if you have a wire with electricity in it and you take a piece of metal, it's not going to stick to it because that magnetic field is really, really weak. But what you can do, there's two ways you can increase the strength of the magnetic field. The first thing you can do is turn the current up because it's the current that causes the magnetic field to exist. The more current you have, the more magnetic field you have. So if you have a big enough current, you can actually take a butter knife and put it next to a wire with a high current in it, it'll stick to it. It's a magnet until the current stops. That's not too practical though. Another way to increase the strength of the magnetic field is, say I have a really long wire with a weak magnetic field. What I can do is coil that wire and kind of scrunch that magnetic field down to a smaller area. I concentrate the magnetic field and it's stronger. So in your 7th grade or 8th grade science class, you might have done this. You might have made something called an electromagnet. If you've never seen an electromagnet or you haven't heard of it, when we're done talking, just go to YouTube and you'll see a basic electromagnet. But it's really easy to make. You can take like a nail or a piece of metal. Take a piece of metal, man. Here's a metal pipe or bar. And what you'll do is just take wire and you'll wrap wire around it. And when you hook it up to a circuit, you close the switch, electricity flows through the wire, and because the wires the coils are smushed together, the magnetic field that exists is concentrated, and now this becomes a really strong magnet that you can control. Just like a regular bar magnet, I have a north pole and a south pole. The thing is, if I open up the switch, the magnetic field disappears. So now, unlike a permanent magnet that's a magnet all the time, an electromagnet is a magnet I can control. I can control this. I close the switch, I got a magnetic field. So if you can imagine that, that's the one thing to understand is how an electromagnet works. The second thing you got to understand is if you have me for circuits, I know most of you have me for circuits, you probably don't remember this. Let me just review something we talked about in circuits. In circuits, if you're with me, we talked about the resistance of wire. And I gave you this formula that the resistance of wire, R sub W, is rho L over A, where rho is called the resistivity of the wire. It's just a constant you don't have to worry about. Depends on the material the wire is made out of. But the thing to understand is the L and the A. The L is the length of wire, and the A is the cross-sectional area of the wire, the thickness of the gauge of the wire. And so you can see from the formula here that R sub W is directly related to the length of the wire. The longer the wire, the more resistance. The longer the wire, if I double the wire, I double the length, I double the resistance. Now that's important because when we make this coil over here on this electromagnet, we have a really, really, really long wire, which means we're going to have a really high resistance. So this coil is a high resistance circuit. Don't forget that. The coil is a high resistance circuit. Why is that important? Well, it's important because if I have a high resistance circuit, remember from circuits course, I equals V over R, where I is the current, V is the voltage, and R is the resistance. If I have a high resistance, that means I have a low current. So this is a low current circuit, a low current circuit. So well, how does that help us? Well, here's what we can do. What I can do is take that coil. I can take the coil and see if you can follow this. If you get this, I'm going to do a back handspring for you. This will make me happy if you follow this. If I take the coil, the electromagnet, here's the wires, I can hook it up to a switch and a power source. And so when I close the switch, current will flow and there's a magnetic field around this. If I open the switch, current stops flowing and the magnetic field disappears. The thing to remember is because that resistance of the wire is so high, this is a low current circuit. I might have milliamps, thousands of amps flowing in this circuit right here. What you can do is take that very same switch that we talked about. You can take the switch and put it close to that coil. And then what they do is they have a really weak spring right here, pulling that pole up, so that's normally open. Now when I close this switch, this magnetizes and pulls that down. These are two separate circuits. There's a space. These are two separate circuits. I can get rid of this thing right here and have a totally different power source here. I can have a battery, and I can have a motor right there. And these are two isolated circuits. When I close this switch, this magnetic field pulls this down. And the key is, this is a low current circuit, but this is a high current circuit here. I can use 10 milliamps. This might be 10,000 amps. I can use a little current to control a lot of current. Example of this would be in your car. This is the thing you turn. You put your key switch here. That's a low current circuit. You turn it, your starter might pull 10 amps. You don't want 10 amps going up to your steering column. So you use a low current circuit. This is your key switch. You turn it, and the thing you hear go clink in your starter is this big contact moving back and forth to run this high circuit current right here. This is your motor. That basically is a relay. Well, you might say, well, Single, then how does that help us? Because now you got two switches where you had one. But the beauty is I can get rid of this, and I might have a microcontroller or a PC, a computer. I can connect that to here and have the computer control the coil and have that computer interface it with a high current circuit. And this contact in the relay, we can hook that up. We can have several relay contacts. We hook up in series or parallel. We can hook these up, and these are called logic relay or logic control relays. So I said a lot real fast, and I don't know when the session is going to end. I think it might be over, but I said a lot. Go to the website, guys. Look at the material there. There's a picture of a relay. Don't memorize any of that. Just look at it. The thing to focus on, though, for the quiz, not this week, but next week's quiz, is going to be the topic sheet and then those objectives for week 1. Okay. Does anybody have any questions or comments before we sign off?
Can you repeat what to focus on for quiz 1? I heard the second part of the objectives, but what was the first part?
Well, here's what I said. I said quiz. I didn't say this. I'll tell you this. Quiz 1, I didn't tell you what it was about, but if you have the IQ of a donut hole, you'll get it. So don't worry about quiz 1. Quiz 2, which will be next Friday, not this Friday. Quiz 2 will be next Friday. You want to look at the objective sheet for that. I didn't tell you what to study for a quiz 1 yet. It'll be real basic stuff. So don't worry about that. I'll surprise you.
All right, thanks. I appreciate it.
Okay, no problem. Anybody else? Okay, guys. Well, have a great rest of the day. Stay safe. I will see you on Monday at 1 o'clock. Any issues or problems, you want to send me a text or email me. And have a great rest of the day, guys. Thank you.
Thank you.
Thank you.
See ya.
Thank you.
Have a good one.
Thanks.